Let's work on comparing fractions. Insert a greater than or less than to form a true sentence. 3/8 and 14/40. Well, it would be nice to say something simple like 3 is less than 14, so less than. But since the denominators aren't the same, we would really have no basis in saying that. 3/8 and 14/40 are unlike fractions. We can't compare them. But if we had a common denominator, then we could compare them. So let's get a common denominator. 40 is a multiple of 8. So we can just do 8 times 5, getting us to 40. Times 5 on the bottom is times 5 on top. 3 times 5 is 15. So we're actually comparing 15/40 with 14/40. Now we can say that 15 of them is more than 14 of them. So this is greater because 15 is greater than 14. So once we found that they were, or once we found the common denominator and wrote them as like fractions, we were able to clearly see that we had greater than. And since that is an equivalent fraction, that means 3/8 is greater than 14/40. We got the opposite of our guess from the beginning. Just goes to show you 3 can be less than 14, but 3/8 can be greater than 14/40. Let's do another. -2/7 and -1/3, putting aside for now the fact that things work differently on the negative side of the number line. They're not as you would initially expect. We need to keep to the rule that the left number is less than the right number. We can't compare until the denominators are the same. We start with 7. 7 is not a multiple of 3. 14 is not a multiple of 3. 21 is a multiple of 3. So 21 is in common to both. 21 is our goal for the denominator. To get -2/7 there, 7 times 3 gives us 21. So on the top, 2 times 3 is 6, -6/21. To get -1/3 there, 3 times 7 is needed to get to 21. So 1 times 7 is 7, -7/21. So we're comparing -6/21 to -7/21, which means we're comparing -6 to -7. And -6 is greater than -7. -6 falls to the right of -7 on a number line. That's what I was saying. Things work a little weird. 6 is less than 7, but -6 is greater than -7. Which means that -6/21 is greater than -7/21, which means that -2/7 is greater than -1/3. An evaluate problem. Evaluate x plus y for x equals 1/3 and y equals -4/5. Plug it in, plug it in. X plus y would be 1/3 plus -4/5 once we make our replacements. We need a common denominator. That's going to be 15. Multiply the 1/3 by 5/5. Multiply the -4/5 by 3/3. That gives us 5/15 plus -12/15. 5 plus -12 is -7. So -7/15. A freight truck has 1/4 ton of computers, 1/3 ton of televisions, and 3/8 ton of small appliances. Find the total weight of its load. We see that keyword total. We know that to find the total weight, we would add the weights of the individual items. So 1/4 plus 1/3 plus 3/8, and that's in tons. 8 is a multiple of 4, but it's not a multiple of 3. 16 is a multiple of 4, but it's not a multiple of 3. 24 is a multiple of 4, is a multiple of 3. 24 would be the LCD. We just started with the largest given number, that's 8. We were looking at multiples of 8 to see if they worked for both of the other numbers. To get 4 to 24, we would multiply by 6. To get 8 to 24, we would multiply by 3. To get 3 to 24, we would multiply by 8. Sorry for going out of order there. I misspoke and I just went with it. So we're multiplying by 6/6, 8/8, and 3/3. Whatever we do to the bottom, we have to do to the top. That gives us 6/24 plus 8/24 plus 9/24. Keep the 24 on the bottom, add across the top. 6 plus 8 is 14. 14 plus 9 is 23. So 23/24 tons is the total weight. And that is it for this topic. The topic is complex fractions and review of order of operations. The objectives in this topic: simplify complex fractions, review the order of operations, and evaluate expressions given replacement values. So a complex fraction is just a fraction with fractions inside of it. So some examples would be 1/4 over 2/3, 1/4 plus 1/3 over 6/11, and 3/4 minus 1 over 6. If there's a fraction inside the fraction, it is a complex fraction. We have two methods to handle this. The first method takes advantage of the fact that a division bar means division. A fraction bar means division. So if we're going to simplify 1/4 over 2/3, that's the same as saying 1/4 divided by 2/3, and we know how to handle that. Keep, change, flip, or keep, flip, change, the Colonel's secret recipe. 1/4 times 3/2. That's 1 over 3, or 1 times 3 over 2 times 2 times 2, because 4 is 2 times 2. We see that nothing cancels. So this is just 3/8. We could have jumped straight there, but we were checking to make sure we didn't have any cancellation first. So 1/4 over 2/3 is 3/8. Method 2 is to multiply the numerator and the denominator by the LCD. The LCD of what? Of 4 and 3. That's going to be 12. So if we multiply by 12 over 12, 12 times 1/4 is 3. 12 times 2/3 is 24/3 is 8. So that gives us 3/8 as well. Personally, I feel if the LCD method is a little bit confusing, just take advantage of that top divided by bottom. Simplify the top so that it's a single fraction, simplify the bottom so it's a single fraction, and then divide. Method 1 is very straightforward. Method 2 takes advantage of canceling techniques, but both are perfectly fine. So we know our operations, and we know the order of operations. Let's apply our operations on fractions to the order of operations process. We know that when we have to multiply fractions, we multiply across the top and multiply across the bottom. When we divide, we keep, change, flip. When we add or subtract, we need them to be like fractions, and once they're like fractions, we add across the top, keep the bottom, or subtract across the top and keep the bottom. We know our order of operations is parentheses or other grouping symbols, then exponents, then multiply or divide from left to right as we come to it, then add or subtract from left to right as we come to it. Putting it all together, use the order of operations to simplify 1/2 plus 1/6 times 1/3. Multiplication comes before addition. So the first step is going to be the 1/6 times the 1/3. Multiply across the top, multiply across the bottom. 1 times 1 is 1, 6 times 3 is 18. Now we have 1/2 plus 1/18. 18 is a multiple of 2, so 18 is the LCD. To get from 2 to 18, we multiply by 9. If we multiply by 9 on the bottom, we have to multiply by 9 on top. That gives us 9/18 plus 1/18, which is 10/18, which can reduce. We can write that as 2 times 5 over 2 times 9, which gives us 5/9. Or divide the top by 2, divide the bottom by 2. But just because we have fractions doesn't mean we handle this any differently. We do multiplication first, then addition. Two-thirds cubed minus 2. Exponent first. 2/3 cubed is 2/3 times 2/3 times 2/3, which is 8/27. In other words, we have the cube of 2, 2 times 2 times 2, over the cube of 3, 3 times 3 times 3. And then we have minus 2 that we need to take care of now. 2 is 2 over 1. The LCD of 27 and 1 would be 27. To get from 1 to 27, we multiply by 27, which means we have to multiply the 2 by 27. That's 54. So 8/27 minus 54/27. Keep the 27 on the bottom. 8 minus 54 is negative 46. And this does not reduce. We can try. They don't both divide by 2 because the 27 isn't even. They both don't divide by 3 because 4 plus 6 is 10, so 46 doesn't divide by 3. They don't seem to divide by anything else either. Next up, this should be fun. -1/2 plus 1/5 in parentheses times in parentheses 7/8 plus 1/8. We work in the parentheses first. Let's work on the left one. -1/2 plus 1/5. We need a common denominator. That common denominator is going to be 10. To get from 2 to 10, we multiply by 5. To get from 5 to 10, we multiply by 2. So the 1/2 is times 5 over 5. The 1/5 is times 2 over 2. We get -5/10 plus 2/10. Now everything in both sets of parentheses has a common denominator. We can add them. In the first group, -5 of them plus 2 of them is -3 of them, so -3/10. And in the second grouping, 7/8 plus 1/8 is 8/8. Well, 8/8 is 1, and anything times 1 is itself. So our answer is -3/10. Let's evaluate. 2x squared plus 3y for x equals 1/3 and y equals -4/5. Plug it in, plug it in. Replacing our x with 1/3 and replacing our y with -4/5. We get that 2x squared is 2 times 1/3 squared. And we get that 3 times y is 3 times -4/5. Squaring 1/3, that's 1/3 times itself. 1/3 times 1/3 is 1/9. Multiplying the +3 times the -4/5, we get -12/5. We can multiply the 2 times the 1/9 to give ourselves 2/9. And now we're stuck at 2/9 plus -12/5. We need a common denominator. 9 is not a multiple of 5. 18 is not a multiple of 5. 27 is not a multiple of 5. 36 is not a multiple of 5. 45 is a multiple of 5. Our LCD is 45. Multiply the 9 by 5, multiply the 5 by 9. Whatever we do on the bottom, we have to do on the top. If I'm going too fast, pause me. Work along with me. 2/9 times 5 over 5 is 10/45. -12/5 times 9 over 9 is -108/45. Keep the 45 on the bottom. 10 plus -108 is -98. So -98/45 is the answer. And that is it for this topic. The topic is operations on mixed numbers. The objectives in this topic: graph positive and negative fractions and mixed numbers, multiply or divide mixed or whole numbers, add or subtract mixed numbers, solve applications containing mixed numbers, perform operations on negative mixed numbers. So if we were to graph these numbers on a number line, we would just need to know their relative positions to whole numbers. -5 is just a dot at -5. -4.5, we could identify -4, but if we want to get another half negative, it would be between -4 and -5. 2 3/4, we could identify 2. Adding another 3/4 to that, we move past halfway between 2 and 3. And halfway between halfway and 3 would be 2 3/4. 1/8 is between 0 and 1, but much closer to 0 than it is to 1. We can imagine it's divided up into 8 equal pieces, and we're just marking the first. And then -1/2. Don't go between -1 and -2. That would be a mistake. 1/2 is between 0 and 1, so -1/2 is between 0 and -1. Halfway in between. To multiply or divide with mixed numbers or whole numbers, the first step is to write any mixed or whole numbers as improper fractions, then multiply or divide as usual. 1 4/5 times 5/36. And now we have no idea what to do. In fact, the only thing we do know at this point is because there is a mixed number in the problem, that means that we need to turn our answer into a mixed number if necessary. So if we get an improper fraction, we need to change it into a mixed number because the mixed number is in the problem. If we get a regular proper fraction, then there's nothing to worry about. Proper fractions don't get changed into mixed numbers, only improper fractions. We absolutely cannot just multiply the fraction parts here. We can't do 1 and whatever 4/5 times 5/36 is. The rule for multiplying mixed numbers, and this is going to carry across to dividing mixed numbers as well. We'll have different rules for adding and subtracting. When we're multiplying and dividing and we have mixed numbers, we must change the mixed numbers into improper fractions before we do our work. It's the only way we're going to get the correct answer. 5 times 1 is 5 plus 4 makes this 9/5. So the problem is 9/5 times 5/36. We can cancel. 5 and 5 is 1 and 1. 9 and 36 is 1 and 4 because they both divide by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. 1 times 1 on top is 1. 1 times 4 on the bottom is 4. And hey, it's not even an improper fraction, so we don't have to worry about taking it back to a mixed number. 1 4/5 times 5/36 is 1/4. Let's do another one like this. Four fifths times 4 7/12. Again, you can't just multiply 4/5 times 7/12. You must, absolutely must, turn this into an improper fraction first. So 12 times 4 is what? 12 times 4 is 48. Plus 7 49, 50 plus another 5. That's 55 twelfths. 55 twelfths. This is why we did practice in the homework with turning mixed numbers into improper fractions and vice versa. This is 4/5 times 55 twelfths. Thank goodness we have canceling. 5 and 55 can both be divided by 5. 5 divided by 5 is 1. 55 divided by 5 is 11. 4 and 12 can both be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 4 twelfths is the same as 1/3. 1 times 11 is 11. 1 times 3 is 3. Can we put 11/3 as an answer? Absolutely not. Why? Because there's a mixed number in the problem. This improper fraction is not okay. We need to turn it into a mixed number. And even if we didn't notice that, there would be a direction probably that says whole number, fraction, or mixed number. And if mixed number is an option and you get an improper fraction, you have to change it. How do we change it? We divide. We're doing 11 divided by 3. 3 goes into 11 3 times. 3 times 3 is 9, remainder 2. 3 2/3. Next. You might be asking, why is it that he just randomly talked about rounding mixed numbers? That seemed weird. It seemed out of nowhere. Well, for this next problem, we're going to multiply two mixed numbers together. 3 1/4 times 2 1/5. We're going to find both an exact product and an estimated product. And when we find an estimated product, that means we're going to round each to the nearest whole number, like we did in the earlier examples, and then multiply those whole numbers together to get a ballpark figure. Here, for the estimated product, 3 1/4, 1/4 is less than a half, so that's about 3. 2 1/5, that's less than a half, so that's about 2. We would have an estimated answer of about 6. To do the exact, we have to do the full work. And remember, when we're multiplying and there's a mixed number involved, we have to change it to an improper fraction. 12 plus 1 makes 13 fourths. Ten and 1 makes 11 fifths. We're multiplying and nothing cancels. So we have to do 13 times 11 over 4 times 5, no simpler way. The bottom, 4 times 5 is 20, we notice. On the top, 13 times 11 is 143. 143 over 20. It doesn't reduce, but it's improper. We're doing a mixed number problem, so we have to get the mixed number. We have to divide. 143 divided by 20. 20 goes into 143 7 times. 7 times 20 is 140. We get a remainder of 3. That goes over 20. 7 3/20. Not 3 times 2 is 6. 1/4 times 1/5 is 1/20. It's not 6 1/20. Absolutely not. Never. You cannot multiply the whole numbers, multiply the fractions, and get the correct answer. The only correct answer is 7 3/20. So this shows that estimating is a helpful tool, but it's not foolproof. What was our estimated answer? Our estimated answer was 6. If I told you the estimated answer was 6 and you had 6 1/20 or 7 3/20, you'd probably think it's 6 1/20 because of the estimated answer, but it's not. The estimated answer is just going to help us if it's like really far off. If we've made a huge mistake, it'll be noticeable, but it shouldn't guide us to thinking 6 1/20 is correct, because we never just multiply the numbers and multiply the fractions. They always have to go through improper form. Let's do it again. We'll estimate, and then we'll find exact. With 7 2/3 times 6 1/8. Let's estimate. Now the homework problems are going to do the other way. They're going to have you do exact first, then estimate. I'm doing estimate first. 7 2/3. 2/3 is over a half, so this is about 8. 6 1/8. An eighth is less than a half, so that's about 6. We're getting an estimated answer of about 48. How do we do it? Same way we've been doing all of these. Improper fractions. 3 times 7 is 21 plus 2 makes 23/3. 8 times 6 is 48 plus 1 makes 49/8. This is it. This is the one we've been afraid for. These numbers are big and nothing cancels. We have to multiply. 23 times 49. So 23 times 49. 9 times 3 is 27. Carry the 2. 9 times 2 is 18 plus 2 is 20. 4 times 3 is 12. Carry the 1. 4 times 2 is 8 plus 1 is 9. When we add, we get that 23 times 49 is 1,127 over 3 times 8 is 24. 1,127 over 24. We need to change back to a mixed number. We do that with division. 1,127 divided by 24. Now you're seeing why we did so much work with division for the last test. We need it. 24 goes into 112. How many times? Well, that's about 25, which goes into 104 times, and 112 is about 100. So let's look at 24 times 4. Let's take a look at 24 times 5 and make sure that 5 doesn't fit in. 4 times 4 is 16. Carry the 1. So that's 96. Times 5 is 120, so 5 won't fit, but 4 does. 4 times 24 is 96. We subtract. 2 divided by 6 can't do it. We're borrowing. 0. 12 minus 6 is 6. 10 minus 9, 16. Bring down the 7. 24 times 5 was 120. That'll definitely fit in. What about 24 times 6? Will that fit in? 6 times 4 is 24. Carry the 2. 6 times 2 is 12. Plus 2, 144. That fits. Does 24 times 7 fit? 7 times 4 is 28. Carry the 2. 168. It just barely doesn't fit. 6 times 24 is 144. Subtract. That's 23. We have nothing else to bring down, so that's our remainder. 46 and 23 24ths is the answer. Not 42 and 1/12. 46 and 23 24ths. This time, the correct way is actually closer to the estimation. But it's not meant to see which answer is correct. It's meant to make sure that we're in the ballpark. And 46 and 23 24ths is definitely in the ballpark of 48. Let's take a look at this one. 3 times 3 4/5. And no, it is not 9 4/5. This is 3/1 times 15 plus 4 makes 19/5. So on the top, we need 3 times 19. That's 57. On the bottom, 1 times 5 is 5. And then we divide. 57 divided by 5. 5 goes into 5 once. 5 goes into 7 once. With a remainder of 2. 11 and 2/5. Not 9 4/5. 11 and 2/5. Let's do another. Let's take a look at 1 1/5 times 6 2/3. Is the answer 6 2/15? No. We have to go improper fractions. 5 times 1 is 5, plus 1 makes 6/5. Times 3 times 6 is 18, plus 2 makes 20/3. I can cancel. 6 and 3, both divisible by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. 20 and 5, both divisible by 5. 20 divided by 5 is 4. 5 divided by 5 is 1. On the top, 2 times 4 is 8. On the bottom, 1 times 1 is 1. 8/1 is just 8. Anything over itself, or anything over 1 is itself. just like multiplication, mixed number division problems need to go through improper fraction form. So when we see the mixed number, even before we change it to multiplication, we need to make this 13 times 1 is 13 plus 1 makes 14 thirteenths times 13 over 1. The 13s cancel, 1 over 1. We get 14 over 1, which is 14. No fraction at all. So no need to worry about making it a mixed number. Well, maybe we'll have to change the next one to a mixed number. 17 21sts divided by 1 6/7. Get rid of the mixed number. 17 over 21 divided by 7 times 1 is 7 plus 6 makes 13/7. Keep the first, change division to multiplication, flip the second. 17 21sts times 7 13ths. 7 over 21, both divisible by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. On the top, 17 times 1 is 17. On the bottom, 3 times 13 is 39. It doesn't reduce, it's not improper, so we can't even make it a mixed number. 17 over 39. Let's do another. 5 1/5 divided by 7 4/5. 5 times 5 is 25 plus 1 is 26/5. Still divided by 5 times 7 is 35 plus 4, 39/5. And now we keep, change, flip. If I'm going too fast for your notes, pause me. 5 over 5 cancel to 1 over 1. We have 26 over 39. This is another one where I would not be surprised if you got to here and did not realize that it reduced. But it does reduce because, believe it or not, there was something else we could cancel. To reduce this, we would have to realize 26 is 2 times 13. 39 is 3 times 13. The 13s cancel, and we get 2/3. Up here, there they were, 13 times 2 and 13 times 3. Fully canceling would give us 2/3. So 11s, 12s, 13s, they might make things a little bit difficult. In the homework, if you would have put in 26 over 39, it would have given you a message something like, not incorrect, not that dreaded red incorrect. It'd be more like a yellow, and it might say, your answer is equivalent to the correct answer, but not in proper final form. And that's telling you, hey, all the work you've done so far is right. You just need to go further. Let's have another. 1 8/9 divided by 3 and 1/6. Mixed numbers to improper fractions. 9 times 1 is 9, plus 8 makes 17/9. Divided by 6 times 3 is 18, plus 1 makes 19/6. Keep, change, flip. 6 and 9 can both be divided by 3. 6/9 would be 2/3. Nothing else cancels, so we would go 17 times 2 is 34. And then 3 times 19 works out to 57. 34/57. Let's do another mixed number problem. See if you're paying attention. 0 divided by 16 and 4/5. Well, we have division involving 0. The 0 comes first and not second. So the answer is just 0. How about if we had 1 divided by 5/9? Well, just because anything divided by 1 is itself does not mean it works the other way. 1 divided by is something completely different. To see this, we would go keep, change, flip. What is 1 times 9/5? 1 times is itself. Our answer would be 9/5. Notice 1 divided by is not itself. It's the reciprocal. We did 1 divided by 5/9 and we got the reciprocal of 5/9. Is that going to work every time? Absolutely. If it was 1 divided by 3/8, keep, change, flip. So then it's 1 times the flip. It's just the reciprocal, 8/3. And if we had something like 2 and 2/5 divided by 0, the 0 comes second. This one is undefined. We wouldn't be able to flip 0 and get a real number. Let's take a look at 29 and 1/3. I'm sorry if you could hear that squeak. At least it's working. 29 and 1/3 divided by 1 and 4/7. So we've got to do improper fractions, unfortunately. 3 times 29 is 87, plus 1 makes 88/3. Divided by 7 times 1 is 7, plus 4 makes 11/7. Keep, 88/3. Change division to multiplication, flip, and we get 7/11. Cancel. 88 and 11, both divisible by 11. That would be 8/1. And why couldn't I finish class without showing an example like this, where we get 56/3? because finally, not there. Finally, a problem with mixed number division where we got an answer that was an improper fraction. And that means we have to turn this improper fraction into a mixed number to match how the problem was given. So we divide 56 by 3. 56 divided by 3. 3 goes into 5 once. 3 goes into 26 8 times. And when we subtract 24, we get a remainder of 2 that we put over 3. 18 and 2/3 would be the answer here. Adding or subtracting mixed numbers. Remember that rule that I drove home for multiplication and division? Not the one about mixed numbers meaning mixed numbers, but the one about mixed numbers having to be improper fractions first. Well, for addition and subtraction, you can throw that rule away. You still can do the improper fractions, but you also can just take care of the fraction parts and then take care of the whole number parts. Please practice. We're going to pick up with addition and subtraction of mixed numbers next time. I'll see you then. So when we multiplied and divided mixed numbers, the number one rule was we had to change the mixed number to an improper fraction before we did our work. With addition and subtraction, that will still work, but we also don't have to change to improper fractions first. For instance, if we had 6 1/3 plus 5 2/9, we can go improper. 18 plus 1 makes 19/3, plus 45 plus 2 makes 47/9. The common denominator would be 9. That means 47/9 doesn't change, but to go from 3 to 9, that's times 3. We go times 3 on the top. 19 times 3 is 57. So this is 57/9 plus 47/9. 57 plus 47 is 104. So our answer so far is 104/9, and we're going to change this back to a mixed number by dividing. 104 divided by 9. 9 goes into 10 once. 9 goes into 14 once. There would be a remainder of 5, which we put over 9. 11 5/9. Put that in just to make sure we were correct, and this is the right answer. Now, this problem done this way, this addition of mixed numbers, required some multiplication, required some division. In there was some subtraction. So all 4 of our main operations are at play when we do it this way. But my point in the beginning was with addition and subtraction of mixed numbers, we don't have to go that route. With multiplication, we would get the wrong answer. But keep in mind that a mixed number, 6 1/3 means 6 plus 1/3. 5 2/9 means 5 plus 2/9. And we can add in any order. So if we change the order around, this would be 6 plus 5 plus 1/3 plus 2/9. 6 plus 5 is 11 plus, this would be 3/9 plus 2/9, 11 and 5/9, because 11 plus 5/9 is the definition of the mixed number. This is also why when we multiply, we can't do it that way, because when it's not all addition, when there's a multiplication in there, we can't just change the order around like we can this way. So for adding and subtracting mixed numbers, we can add the whole number part and add the fraction part. Let's do another. 1 1/6 plus 6 2/3. This is written vertically, no difference than if it's written horizontally. This actually just gives us space over here to get our common denominators. So the common denominator for 3 and 6 would be 6. So this one stays 1 1/6. But here we're going to be adding 6 and some number of sixths. To go from 3 to 6, it's times 2. 2 times 2 is 4. 1 plus 6 is 7. 1/6 plus 4/6 is 5/6. So 7 and 5/6. Let's do another. Our next one's going to be given as 5 3/4 plus 3 4/5. We need to change them so that they have a common denominator. And for 4 and 5, that denominator is going to be 20. So 5 and some number of 20ths. How did we go from 4 to 20? That's times 5. 3 times 5 would be 15. How do we go from 5 to 20? That's times 4. So 4 times 4 would be 16. When we add these, we get 8 and 31/20. And we can't use this as an answer. Why not? Well, we turn improper fractions into mixed numbers. Therefore, mixed numbers can't have improper fractions inside of them. So what we need to do is carry the 1, but a mixed number version of that. Watch this. 8 and 31/20 is 8 plus 31/20. If we change 31/20 to a mixed number, we get a remainder of 11, which goes over 20. 31/20 itself is 1 and 11/20, and we add the 1 to the whole number we already had. Final answer, 9 and 11/20. So make sure when you get your final mixed number form that there is not an improper fraction in what you're trying to use as your final answer. This does not become an issue if you take it to improper fractions first. So if you're choosing to do it that way, that work would look like this. 5 3/4 would be 23/4. And then 3 4/5 would be 19/5. You don't need the original problem anymore. These are both going to be over 20. 4 times 5 to get to 20, so we need 23 times 5. That's 115. 5 times 4 to get to 20, so we need 19 times 4. That's 76. Add, we need 115 plus 76. That's a 191 20ths. And then we divide. 191 divided by 20. We go in 9 times. It's 180. Subtract, we get a remainder of 11 that goes over 20. Same answer. So you don't have to do any carrying if you go with improper fractions first. Let's do another. Let's look at 1 7/10 plus 5 3/10. 1 plus 6, or 1 plus 5 is 6. And since these are both already tenths, 7/10 plus 3/10 would be 10/10. 10/10, not a proper fraction. The big number, or the top number, is not smaller than the bottom number. They're the same. And we know what 10 over 10 is. Anything over itself is 1. Our answer is 7. If we went with improper fractions, 10, this is 17/10 plus 10 times 5 is 50, 53/10, which would be 70/10, which is 7. Either way, you get the same answer. That's new for addition and subtraction. Multiplication and division, we know we would not get the same answer. Let's do another. 13 1/3 plus 14 5/9. We need to get a common denominator. That's 13 3/9 plus 14 5/9, which would be 27 8/9. No muss, no fuss. Five 1/19 plus 8 18/19. If you want to rearrange, you can do that. 5 plus 8 plus 1/19 plus 18/19. 13 plus 19/19 is 13 plus 1 is 14. Or you can write it vertically, that's fine too. 5/19 plus 8 18/19, 13 19/19 is 13 plus 19/19, which is 13 plus 1, which is 14. Or you can go improper fractions, but we're not going to show it that way. That's a lot of work, and we know it's going to get the same answer.